Hi students, I am really super excited to be here just for you. A pleasing welcome to all. This is Gopal from Department of Chemistry, Bharathidhasanar Matriculation Higher Secondary School, Arakkonam, and our new branch is established in Kavaripakam. Today we are going to see 12th standard second unit. Our today's topic is properties of p block elements. Shall we go to the topic? Yeah. Let's see students, we already know that the p block elements are present in the periodic table from the group 13 to 18, and generally the p block elements contains an electronic configuration NH2 NP1 to 6. How can we find the general electronic configuration for p block elements? Now look at see. For example, let us consider the first atom of p block elements, boron. Why it is said to be the first atom? For example, if you consider the boron, its atomic number is 5. So, you can know that the electronic configuration of boron atom is 1s2, 2s2, 2p1. Look at here students, in which the first electron first enters in the p block for the first time in the 2p orbital. So, boron is the first element in the p block elements, and our next element is carbon. So, among the period, the next element after boron is carbon. So, its atomic number is after 5 as 6. Carbon's atomic number is 6. So, its electronic configuration is written as 1s2, 2s2, 2p2. And what is the next element? Good. After carbon, the next element is nitrogen. The nitrogen is atomic number 7. So, its configuration is 1s2, 2s2, 2p3. While you writing the atomic number, you want to calculate the electronic configuration electrons 2 plus 2 plus 3. So, totally 7 electrons is present here. So, the number of electrons should be equal to the atomic number. Our next element is oxygen. For oxygen, the atomic number is 8. Atomic number represents the number of protons present in the atoms. It is equal to the number of electrons also. So, the number of electrons for oxygen 1s2, 2s2, 2p4. Our next element fluorine. Its atomic number 9. Its configuration 1s2, 2s2, 2p5. The last one, neon. In the first period, the elements are present from boron to neon. The neon's electronic configuration is for 10 electrons because atomic number for neon is 10. Its electronic configuration is 1s2, 2s2, 2p6. So, see students, in which you can see the common number is repeated for the s orbital. The common number is 2. So, the common number is written as a constant number n, s, and s orbitals are always being in the fulfilled shape. So, s2 is represented as ns2. Look at here, the s number also equal to the p number. So, for p also we can write n. The p orbital only varies from 1 to 6 numbers, 1, 2, 3, 4, 5, 6. When the p orbital attains 6 electrons, it is satisfied because the large number of electrons is responsible for p orbital is only 6. After 6, the electrons enters to the next orbit level. So, 2p1 to 2p6 is the maximum electrons can entering into the p orbital. So, its general electronic configuration is ns2 np1 to 6. You note it students, it is the public examination 1 mark, the general electronic configuration for the p block element. It is responsible for the second block. So, 2s2, 2p1 to 6 is the general electronic configuration for the second orbit. If you want to write the third orbit means you choose 3s2 3p 126. So, the number in front of the s orbital and p orbital is the representation of the orbits along the atom. If you consider one atom, it contains a nucleus. The first orbit contains 1s and the second orbit contains 2s and 2p. As like the third orbit may contains 3s, 3p and 3d. So, for writing the correct electronic configuration, take it the general electronic configuration NH2 NP126. Note this point. This is the first characterization as the electronic configuration for p block element. Our next one is the next characteristics of p block elements as in the periodic table. Let us look at the periodic table in which the first two groups are represented as S block, because the last electrons enter in the S block. So, only it is called as S block, and the p blocks are present in boron 2 neon groups. For example, the first boron contains p1 and neon atoms contains p6. So, from 1 to 6, the 6 groups present in right side are represented as p block elements, and the center block is D block. The last one in the bottom is F block. So, S blocks contains S1 and S2. So, only it contains 2 groups, as like P blocks wants P1, P2, P3, P4 and P5. So, it needs up to 6 electrons. Whenever the 6 electrons are filling in orderly, the 6 groups are taken in the periodic table. So, p blocks present in 6 groups. So, this is the position and arrangement of p block elements in the periodic table. By this, we can study the characteristics of periodic table with the p block elements. Let us see, students, in which the first character is the metallic character. Do you already know that the metallic character is responsible for the metals? Metals what do in a reaction? In a chemical reaction, metals only first donate the electrons to make the bonding. That bonds are metallic bond, or metals reacts with the another non-metal means it can form ionic bonding. So, whatever the bond will make, the metals donates the electrons first. So, metals or metallic character is to donating the electrons. For your example, I take the metal atom sodium first, Na. Let us see here, Na sodium atom contains the atomic number 11. This the number of neutrons, protons and electrons when write for sodium metal, protons may contain in 11 numbers and neutrons, additionally one neutron is added in the sodium metal atom. So, when we calculate the mass, 23 is taken for the mass number, and number of electrons always equal to proton, you know. So, the electrons present in the sodium metal atom is 11. So, 11 number of electrons I write here. Here 2 electrons will be present in s orbital and remaining 2 electrons and 6 electrons can occupy the space in the second orbit. First orbit containing electrons are represented as 1s2. Second orbit electrons are represented as 2s2 and 2p6. You see, students, in which 2 plus 2 plus 6, totally 10 electrons are represented in this electron. So, only 1 electrons we need to show because total number of electrons is 11. The last 1 electron enters in the third orbit. Let us see, students, if we do not consider the last electron, its atomic number is 10 and it contains 10 electrons. The neon atom only contains atomic number 10 and so it contains 10 electrons. You already know that the neon atom is a noble gas or inert gas. It is very stable. So, sodium also wants to behave like a stable compound. To get a stabilization, it wants to get a electronic configuration like a neon atom. So, to get change into neon atom means it want to remove one electron because it additionally contains one electron extra. So, sodium like to remove one electron and then the sodium can form Na plus. Whenever the metal donates electron, it can form Na plus. Why they are donating electrons? To get a stabilization like a noble gases. So, this property, donating the electrons property is the metallic character of the atoms. In p block, large number of atoms contain the metallic character because they have high effective nuclear charge and they are having the property of donating the electrons. So, whenever the atoms donating electrons, they have the metallic character. P block elements contains a variable metallic character. So, first one is metallic character, and metallic character is the property of donating the electrons or tendency to donate the electrons to involving in the chemical bonding. And next property for p block elements is atomic radius. To find the atomic radius, what we want to do? You already know that atomic radius is the distance from which to which? Right, from nucleus to the last outermost electron, correct. Now, I draw one atom, it is the nucleus of the atom means it contains many orbits in which the last orbit contains last electron, you know, that distance is the radius of atom. So, radius is nothing but the distance between the nucleus to last outermost electron. For the atomic radius, we need to calculate the distance between the nucleus and the electron. So, how can you write the atomic radius definition? The atomic radius is nothing but it is the distance between the nucleus to last outermost electron. So, this is the correct definition for the atomic radius. But if you have a molecule means, now I draw a molecule, it contains two atoms, one is hydrogen, another one is hydrogen. So, it is a H2 molecule, the molecule is H2. For this, the atom is not alone or being single, it is combined with the another same type of atom. So, for this atom, if you want to calculate the atomic radius means, you need to calculate the distance from outermost cell to the center nucleus. So, this is the radius. Another character is, it is inert pad effect. Inert pad effect is nothing but same like the metallic character of the atoms. Metallic character of the atoms denotes that the atoms gives the electron to get the stabilization and behave like a metals. To get the stabilization, they losing the electrons, you know, the tendency is inert pad effect. So, inert pad effect means every atom contains nucleus, inside the nucleus contains protons and neutrons. In the outer side, it contains electrons. The atoms like to lose the electrons to get the stabilization. To get the stabilization. So, look at one matter, when it loses electrons, it can get a completely filled or half filled electronic orbital. When the atom gets a completely filled orbital, then only it gets stabilization. What is completely filled orbital? For example, sodium may contain in its large cell p block and s block. For sodium, in the s block, last s block contains one electron and p block contains completely fulfilled electrons. This is the correct electronic configuration for the sodium. Here you can see 2p is completely filled, but 3s contains only one electron extra. So, this electron when going out, the p orbital fully completely filled configuration is responsible for the sodium. So, the sodium can be get a stabilization. So, to get the stabilization, the sodium send out one electron to the other atom and it changes into Na plus and sodium is get stabilization. So, this method is called as inert pad effect of the atoms. The anomalous characteristics is nothing but the 3 special characters of p block elements. What are them are the 3 special characters? First one, the p block elements are smaller in size, very smaller in its size. So, look students, when we comparing p block elements with d blocks and f blocks, d blocks and f blocks are containing higher orbits and higher atomic number, so they are higher size, but the p blocks only we containing lower size than the d block and f block, so they are generally smaller in size. Because the effective nuclear charge of the p blocks are higher. Let us see, the effective nuclear charge is nothing but the nucleus attracting the outermost electrons. So, whenever the nucleus attracting outermost electrons, then atom gets reduced in this size. So, get reducing its size oneself and then the size of the atom is decreased. So, radius of the atom also decreased. This is the special characteristics of p block elements. And next anomalous property is they have high electronegativity. Higher electronegativity. It means the electronegativity value for the p block elements is higher. Students, the electronegativity we already studied about this in the first chapter. The electronegativity is nothing but the attraction of electrons among the nucleus. The nucleus present in the atom like to attract the electrons from the other atom. If you have 2 atoms, one atom is positive atom and next one is negative atom, means the negative atoms like to attract the electron from the positive atom. For example, sodium and negative atom chlorine. When sodium donating its electrons, it is Na plus. When chlorine accepting sodium's electron, it gets into negative charge Cl minus. So, the attractive property of the chlorine atom from the sodium, the electron is attracted, it is the property of electronegativity. So, electronegativity is nothing but the atom's tendency to attract the electrons from other atom. Electronegativity also can be defined as a shared pair of electrons is attracted towards itself. So, chlorine atom's electron and sodium atom electrons both are attracting towards the chlorine. So, only it contains the minus charge. This is electronegativity. So, electronegativity for the p block elements is higher. And the third one, it is very easy. P block elements do not contain d block elements, and d block elements containing electrons will not be present in the p orbital. P orbital only contains the p block elements and p block electrons. So, the d block electrons will not be present in the p block. So, d block electrons are absent. It is very easy to know that because p block elements do not attract the electrons from d block. So, d block elements containing electrons will not be present in the p block, it is absent. So, this is the special characteristic of p block anomalous properties. Let's see, smaller unit size and high electronegativity and d block elements are absent. This is the 3 points for anomalous properties. Do you understand, students? For any further clarification, you can ask me in the doubts. Okay, students, by means of their special characters, the questions are given in the study materials. In the YouTube description, you can see the study material. The study material contains the pages with the book background marks and additional questions, and all the problems are given in stepwise, and important formulas and definitions also given in the study materials. You simply download the study materials. It contains a self-assessment question paper also. Write the self-assessment test and send us a photography for corrections. Thanks for making time to watching this video. Thank you.